This video lesson is about the components of a refrigeration system. And a refrigeration system works the same way whether we're talking about a refrigerator in a home or a walk-in cooler in a restaurant or a refrigerated case in a supermarket or in an HVAC system which heats and cools your house or your building. So first of all, as far as components of this system goes, probably the most mysterious is the refrigerant. And the most common refrigerant for HVAC systems today is R410A, which boils at nearly 50 degrees below zero. So this refrigerant wants to be a gas, and the only way we can keep it as a liquid and use it in a refrigeration system is to put it under a lot of pressure. Now, how do we put it under pressure? Well, with the first component that we're talking about is the compressor. And the compressor is what takes the refrigerant gas coming in this way on the suction side of the compressor, and it compresses that gas, that cool gas, down into a very hot gas. And the hot gas makes its way over here into the condenser. And the gas that's going into the condenser may be, let's say, 120 degrees. Well, why did we compress the gas? Well, the gas is full of heat that we have collected, and we want that heat to either go into the building in the case of a heat pump, or when we're air conditioning, we want it to go into the outside air. Well, if we're going to use, 90 degree outside air, outdoor air, to cool this coil, well, then the coil has got to be a higher temperature. So the second law of thermodynamics says that heat moves from a higher temperature to a lower temperature. Okay? So the outdoor air is at a lower temperature. It's at 90 degrees. And the refrigerant inside the tubing is at 120 degrees or 100. Actually, it would be much higher than that. And so we get the air coming in at 90 degrees and coming out at 120 degrees. And so that's how we're moving the heat from the building to the outdoors. So what makes the refrigerant give up its heat? Well, this hot gas coming in here turns to a liquid. It's like if steam in a radiator turns back to liquid water, it releases all that heat that we call latent heat that was contained in the water. And that's the same thing the refrigerant does. When the refrigerant comes in here as a gas and it turns back into a liquid, it's like steam turning into water. And the heat that was collected over here in this coil, the evaporator coil, is then discharged in the condenser, and the air moving through the condenser takes that heat into the outdoor air. So now, coming out of the condenser, we have a liquid. And the liquid flows over here to the next component of the system that we want to talk about, which is the expansion device or metering device. And this is a valve. It's actually a nozzle. And this liquid is still under high pressure because it's connected to the discharge side of the compressor. So this liquid is under high pressure, and we're going to drive the liquid through this nozzle here. And when we drive the liquid through the nozzle, it gets sprayed into the evaporator. And It gets sprayed, and as it gets sprayed, it's turned from a liquid into droplets and then into a gas. And when that happens, it's like when you take hairspray or spray paint or something, and you push down on the button of that spray, and what do you feel in your finger? Well, your finger starts to feel cold, and if you sprayed for long enough, even if it was a warm day, you could frostbite the end of your finger. And that's because when a liquid is turning into a gas, it is sucking heat from everything around it. And what it's doing here in the evaporator, okay, this is the evaporator coil. What it does in the evaporator is it sucks the heat out of all this metal. And the metal is copper tubing and aluminum fins. And at the same time that it's sucking the heat out of there, we're driving air from the building. For example, at 75 degrees, we're driving air from the building, which is 75 degrees, through this coil. It comes out the other side at 45 degrees. There's a 30-degree temperature split, or some other number of degrees. This is how the evaporator works. This is how we're cooling the air inside the building. So then we circulate this air with the air in the building and cool the building. So what happens once the gas comes out the other side? It goes back to the compressor. And right now, this gas may be somewhere between 55 and 65 degrees, something like that. And it comes back here and is compressed by the compressor again, and it leaves the compressor maybe at 140 degrees, something like that. So we have the refrigerant traveling around in the circle. It's driven by the compressor. The compressor compresses the cool gas into a warm gas. It goes over into the condenser. It condenses, releasing its heat. The outdoor air enters at 90. It exits at 120. The heat that was collected over here is moved into the outdoor environment. Then we have the liquid coming over here to the expansion device or metering device, sprayed into the evaporator, becoming a gas again, and in the process sucking heat out of the air and out of the metal and cooling the air in the evaporator, and the gas comes out of the evaporator and back into the compressor. So those are the components of the refrigeration system and how they work.